Okay, finding probability using counting principles. So last unit's stuff. Okay, so we have Jamal, Ethan, and Albert. They're competing with 7 other boys in a cross-country event. They all have the same chance of winning. Determine the probability that Jamal, Ethan, and Albert will place first, second, and third in any order. So I'm trying to give them medals. I want the 3 of them to have medals. Okay, so remember what probability is. The situation you want divided by all possible situations. So what is the situation that I want? The 3 of them getting the medals. Divided by all possible. Okay, so if I'm only working with the 3 of them and then giving the 3 of them medals, so the situation I want is those 3 people and those 3 people getting medals. That's the situation I want. So that would be those 3 people and I'm giving medals to those 3 people. What's the letter you would like to put in between? Am I doing just the grouping of these people, or am I worried about the ordering of these medals? I actually am going to do a P. Because Jamal could get the gold, Ethan could get the silver, and Albert could get the bronze, or I could give Ethan the gold, the silver, the bronze, right? Divided by all possible. So what is the whole situation of awarding medals? Entire possible medal awarding ceremony. Seven others. So there's 10 kids in the race, and you're giving medals to 3 people. Okay? So the situation you want divided by the all situation. Very small thing. Very small chance that the 3 of them would be getting the medals, right? Okay, so on this one we're using 5, 4, 7, and 1, and we're trying to make a 4-digit code. What's the probability that the code is even? So I'm going to talk about how could I make even codes divided by what are all possible codes. I guess we should have talked about repetition. There should have been some kind of information. Okay, sorry, I should have provided something because you need to know that, right? I'm going to go that repeats are allowed. Okay, how do you make something even? What do you know about numbers being even? It has to just end in the even. That's it. Some of you on your test thought you needed to put even numbers in every single position. For a number to be even, you only care about the last thing. So go to here. What could you do here? What are my options? I only could put a 4 there, so I only have one option there. Okay, repeats are allowed. How many options do I have here? 4, 4, 4. I can use anything I want. That make sense? You can use anything. You can use that 4 again if you want. Divided by, okay, what's the all possible? This isn't even anymore. It's just anything. What could be any code? 4, 4, 4, 4. Okay, you can divide that, but you know what I did? I canceled, I canceled, I canceled. Okay, we're doing a radio show in Saskatoon. The advertisement for his show. He's holding a contest. He spells out Saskatchewan with tiles, and then he turns the tiles face down, mixes them up, and he asks Sally to arrange the tiles in a row, turning them up, and if it spells Saskatchewan, she would win a car. What's the probability that she would win? Okay, so how many arrangements could there be in these letters? What do you do again? Arranging letters. You do the, how many letters there are? Does anybody else count 12? Okay. You arrange with 12 letters, but then what happens? Cancel, divide, anything that was a repeat. Because if I switch an A with an A, that doesn't make a difference to you, right? So what do we got? 1A, 2A, 3 A's, 2 S's. Any other letters? No, that's it? Okay, so remember when you do that division, you should put brackets in that situation, right? Okay, so that's how many arrangements there are. So what's the chance? What's the probability that she is going to have the one arrangement that she wants? 1 out of. There would be only one arrangement that would be possible for her to win. So that's how you do a probability on those situations, 1 out of that many options. Okay, Blake has 3 children. Determine the probability that at least one of them is a boy. Okay, so what does that mean when you say at least?
You could have 1 boy and 2 boys.
1 boy, you could have 2 boys, you could have 3 boys. So FYI, if you had 1 boy, that would mean there's 2 girls in that family. Okay, so what's the chance of having a boy? When you have a baby, what's the chance that it's going to come out a boy? 50%, yeah, 1/2. What's the chance of having this child be a girl? 1/2. 1/2. Okay, but do you remember this? I could have done the boy be the middle child, or the boy could have been the youngest child. So what am I doing? I'm timesing by 3. because I have to choose one of the positions for that boy to be in. Okay, so that is 3. So the whole top is 1 times 1 times 1 times 3. And the bottom would be a 2, 2, 2, which is 8. Whoop. The tops of the fractions are 1, 1, 1, and then this would be times the 3. Okay, so then having 2 boys and a girl. So that's a 1/2, 1/2, 1/2. But what am I doing about the scenarios? I have those 3, and I'm trying to choose 2 of the positions to put the boys in. This is actually 3 as well, because look at your arrangements. You could go what? Boy, boy, girl. What else could you do in that family? Boy, girl, boy. That's number 2.
Girl, boy, boy.
Girl, boy, boy. So that's the 3rd, right? So this is also 3/8. And then the scenario would be boy, boy, boy. 1/2, 1/2, 1/2. And there's actually no other ways to do that, right? If you really want, you could say you're doing 3 boys choosing the 3, but that's just 1, right? Because you can't, what else can you do with boy, boy, boy? Can't change that scenario, right? So that's 1/8. So what do we do with scenarios when we say this scenario or this other scenario could have happened? What am I doing with my numbers now? I'm adding, so 7/8. You have a 7/8 chance of having at least 1 boy in the family. Okay, method 2. What do you think the other method would have been? What kind of other strategies have we sometimes done? All minus complement. This is called complement, by the way. You've probably run into that on your sheet. Opposite complement event. Okay, let's talk about what's opposite of this. When we had at least 1 boy, what would be an opposite family? No boys, which means there would have been a girl, and a girl into that family. So 1/2, 1/2, 1/2. You technically don't have to do anything else because there's no way to move around girl, girl, girl. So that is 1/8. So what is an all probability? What's the all scenario? 1. So I'm going to say 8/8 because that's an entire probability is always 1. And did we get to the same answer? Okay, there's 8 people in a line. You and your best friend are in this line. What's the probability that you're going to be beside your best friend in this line? So I'm going to draw my 8 people standing in line. How do I make me and my best friend stand beside each other? What do? I glue us together. How many things are you moving around? 7. And then what are you and your friend doing beside each other? You're moving. So that's the scenario of us beside each other, divided by what are all the potential options here? Just anybody. Bless you. So then I would be on my calculator typing that with probably a bracket just to be safe. Okay, probability, you can again express it decimals, you can be in a percent, you can be in a fraction. Okay, next one, you have 9 girls and 10 boys in your class, and you got to make a committee of 4 people. What's the probability that they'll have the same number of boys on your committee? So what am I doing in this if I want to have the same boys and girls on my committee? What is my committee doing? What's on my committee then? 2 boys and 2 girls. So how do you do 2 boys? 10 choose 2. And this is the same committee, so it's a multiplier. I need 2 girls. 9 choose 2. Out of, if there was no restrictions, what is just anything I could do on my committee? 19 choosing 4. Okay? And then you get a number when you do that. Okay, I'm actually going to give you a secondary question here, just to make you practice something different. What if I said, what's the probability that your committee will have just one gender on it? So what's the probability that you'll end up with just one gender? So tell me what your committee could look like. You could have all girls. Is there another scenario? Or you could have done something that would have had all boys. So what would your committee look like if there was all girls? 9 choose 4. And a committee with all boys would have been a 10 choose 4. What would you do with that? You add, because those are different scenarios. They're not on the same committee, same time. Those are like this or separately this. Okay, we don't need to calculate it, but I just wanted to show you that process, okay? So this is all last unit putting it together though.